All right, let's talk about the invisible architecture of our world. We're going to build with science's Legos today. And seriously, if you've ever clicked a few of those bricks together, you're already halfway to understanding one of the most important concepts in all of science. Let's dive in. So, let me start by asking you a question. What could a plastic water bottle, a nylon jacket, and get this, your own DNA possibly have in common? I mean, they seem totally different, right? But believe it or not, they all share one fundamental secret. And the answer is, they're all made of polymers. Yep, that one word connects the synthetic things we make, the natural world around us, and even the biological code that makes you, you. It's pretty much the secret ingredient to, well, almost everything.
So, what in the world is a polymer? Okay, the official definition sounds super technical, right? A large molecule or macromolecule made of many repeated subunits called monomers. Yeah, that sounds like a textbook. Don't worry about that. We're going to make this way, way simpler.
To understand any huge structure, you've got to start with the smallest possible piece. So, first up, let's meet the monomer. This is our absolute basic building block.
So a monomer is just this tiny single molecule that has a special superpower. It can link up with other molecules just like it to form a chain. But you know what? Let's just forget the chemistry words for a second.
Just picture one single Lego brick. That's it. It's a single unit, it's ready to connect, and it's the starting point for absolutely everything else. That's your monomer. Simple, right?
Okay, so we've got our single brick. Now for the fun part. How do we get from one lonely brick to a whole long chain? Let's look at how we actually build something much, much bigger. This whole building process has a fancy name, polymerization, but all that really means is it's the action of joining those monomers together. So, if the monomer is the Lego brick, polymerization is just the act of clicking them together. That's it. And the process is so simple, it's beautiful. You start with a pile of your individual bricks. Those are your monomers. Then some kind of chemical reaction happens. That's the satisfying click that links them up. And you just keep doing that over and over. And suddenly, you've got this long, stable chain. And that chain, well, that's your polymer.
Now think about it. Not all Lego creations look the same, do they? You can build a long, straight line, or you can build a crazy, complex castle. Well, the exact same thing is true for polymers. And these rules of the build are what give different materials their totally unique properties.
The very first rule of the build is something called functionality. It just means how many connection points a monomer has. Think about a Lego brick again. Its functionality is just the number of little studs on top it has to connect to other bricks.
And this functionality changes absolutely everything. A monomer with just 2 connection spots, we call that bifunctional, can only build in a straight line. It makes these simple linear chains, kind of like what you'd get from a basic 2x1 brick. But a multifunctional monomer, one with more than 2 connection points, that's like a corner piece or a cross-shaped piece. It can branch out, connect other chains, and build these complex, rigid 3D networks. That's the difference between a flimsy plastic bag and something super hard, like a bowling ball.
We've been saying these chains are long, but what does that actually mean? How long are we talking about here? How many of these tiny molecular bricks actually make up one single polymer molecule?
The scale is just mind-blowing. We're not talking about a few dozen or even a few hundred. A single polymer chain is often made of 10,000 or more monomers all linked together. That incredible length is what gives materials like nylon their amazing strength and toughness. It's why we call them macromolecules. They're gigantic. And of course, there's a term for this. The degree of polymerization. Sounds complicated, but it's just the official name for the total number of bricks in your final creation. And that number is so important. It tells you almost everything, from how strong the material is to what its melting point will be.
Okay, phew. We've covered a ton of ground, right? We've gone from single tiny bricks to these massive chains that literally make up the world around us. So let's pull it all together into a quick, simple playbook so it all sticks.
You know, I love this quote. It's so perfect. Understanding polymers is like learning the fundamental grammar of the material world around us. It's not just some abstract chemistry thing. It's about learning the rules for how stuff gets made. It's the language that everything is written in.
So here it is, your polymer Lego set all boiled down. The monomer, that's your single Lego brick. The polymer, that's your final awesome Lego creation. Polymerization is just the fun part, the act of clicking those bricks together. Functionality tells you what kind of brick you're using. And the degree of polymerization? That's just counting up how many bricks you ended up using. See? You've totally got this.
So there you have it. You now have the blueprint for a massive part of our world, from the simplest plastics to the most complex parts of life itself. These are the building blocks and the rules we talked about to find the properties of almost everything you can see and touch. So the only question left is, now that you know how it all works, what will we build next?